Hi there, so in this video I'm going through some of the practice problems from slideshow number 16 on page 44. These are the conditional derivation examples. I'm going to start with the first problem and go through all four of those in this video. So the first one is the following. We've got our premises here. P arrow Q, premise 2, not Q or R, and then we're trying to show P arrow R. We need to make our notation there, so we're going to write PR here for premise. And of course we leave the show line open because we don't know exactly how we're going to prove it. What we've been working on here is how to handle show lines like this, that is conclusions, whose main connective is a conditional. And we talked about, in the last video, how to do what we call conditional derivation. So that is to show P arrow R, that is to show if P then R. We're not going to directly show P arrow R. Instead what we're going to do is we're going to assume P and then try to show R. And if we can do that, if after the assumption that P we can show R, we'll be done with our proof. So let's see how that goes. So first we want to put P here and write down AS for assumption. And then immediately after that we're going to write another show line, show R. That is, we assume the antecedent and try to show the consequent. So how do we proceed? Well, now we've got P and we've got P arrow Q, so arrow out tells us we can get Q, and that comes from 1 and 4 by arrow out. What do we do next? Well, we're trying to get R. We've got not Q or R, and we've got Q. If we had the negation of not Q, we could get R out of that by or out. So I'm going to double negate Q to get not Q. That comes from 6 by dn. And now with line 7 and line 2, we can get R, that's 2 and 7, by our or out rule. So now we've shown R, which is what our show line on line 5 had us try to do. So this is, the show line on line 5 is itself a direct derivation. How do we know that? Well, the thing we're trying to show, R, is at the bottom of our proof, R. So we know it's a direct derivation. We cancel that show line and box everything that comes underneath. And I'm just going to do a partial box like this now just to save some writing. So look what we've done. After assuming P, we were able to show R. That's what the canceled show line means. But if on the assumption that P we can show R, that just means that if P is true, then R is true. So we've actually shown if P then R, and this now is a conditional derivation. And so we use the notation CD for conditional derivation. And you can tell it's not a direct derivation in this case because we're able to cancel the show line P arrow R, even though you'll notice P arrow R does not appear at the bottom of our proof. That's okay though. This proof technique allows us to cancel a show line of that form when after assuming the antecedent, we're able to show the consequent. So we box and cancel, and that's the end of that particular proof. Let's try one more example here. Let's see if I can make this work here. And then we'll do examples 3 and 4 on the next video. So number 2, example number 2 here, is the following. Premise 1 is P and Q arrow R. It's a premise. And we're trying to show if P, then if Q, then R. All right. So we've only got one premise here and then a show line. Notice the connective for our show line, the main connective, is arrow here, which means we can do conditional derivation. we assume the antecedent, in this case p, and then try to show the consequent, q arrow r. So I'm going to go ahead and try to do that. I'm going to assume p. I'll move this over to make sure we have enough room. And then immediately after that, I'm going to write down another show line with the consequent. In this case, the consequent is q arrow r. Okay, now let's think about what to do. We've got a new show line here, q arrow r, and we have to think about how to proceed. Well, what's the main connective of this show line? Ah, again, it's an arrow, which means we're going to do conditional derivation. We're going to assume the antecedent, in this case q, and then try to show r. So we assume q, and then we try to show r. Now let's just think about what's going on here. If we're able to show r, then because we showed r after assuming q, we will have shown if q then r. But if we're able to show that after assuming p, then we'll have shown if p, then if q, then r. And so we'll be done with our proof. So really now all we have to do is try to show r. And just notice that the lines we have available are our initial premise as well as our two assumptions. And once you see that, it should be pretty easy to see how this proof or this derivation is going to proceed. From 3 and 5 we can get p and q, 3, 5 by and in. And then, now that we have p and q, and we have if p and q then r, we can get r. And that comes from 1 and 7 by arrow out. Now we just have to wrap up our proof. We set out to show r, and r is at the bottom of our proof, so that's a direct derivation. We cancel it and we box. We set out to show if q then r, and we did that by assuming q and showing r, so that's a conditional derivation. And finally, after assuming p, we were able to show if q then r, which means that if p is true, then q arrow r is true. So that's a conditional derivation, and we cancel and box. And so there's the first two practice problems on page 44 of slide 16 called conditional derivation examples.